Good afternoon, everyone. I'm Thapa and I'm working with Atmosphere Initiative. Since Dr. Bave has already discussed about some of the major pollutants and its sources, I'll be basically dealing with the instruments that can measure these pollutants. The brief outline of my presentation. Firstly, I'll be discussing about the pollutant measurement techniques, followed by instruments. I'll be discussing about three major instruments: MicroAeth, Indoor Air Quality Probe, and Aerosol Mass Monitor. And finally, for a complete study, two methods are involved. First is data collection, and second is data processing and analysis. So I'll be talking a little bit about that aspects. So whenever we talk about air pollution monitoring, air pollutant monitoring, we will basically be following one of the two principles. First is ambient air monitoring. That is nothing but the study of long-term assessment of the type of pollutants present in the outdoor air or the surrounding. So that gives us the idea of the quality of air that we are breathing. And the second one is emission measurement. That is also known as source testing, which is basically the study of the pollutants from a specific source. It's a point source. So, for example, from brick kilns or the industrial chimneys, that comes under emission measurement. The instruments we'll be talking about now is personal exposure instruments. So that helps us to know about the quality of air we are exposed to. The first one is MicroAeth. So Aethlometer is an instrument that measures black carbon. It's a microwave oven-sized instrument that's in ICIMOD. You'll get to know about it in the upcoming days. Whereas MicroAeth is a smaller version of the Aethlometer. It basically measures the black carbon. So basically there are filters which we insert inside. These are the filters. And the working principle is like light is passed through the filters, and first, since the filter is clear, all the light passes through it, whereas as the black carbon aerosols get deposited on the filter strip, the light gets attenuated. And finally, based on the deposits, the final mass or the concentration of the black carbon is measured. Also, you can measure it on different time bases, whether it be 10 seconds, 30 seconds, 60 seconds, or 300, based on the objective of your study. And you can also control the flow rate, say like 50 milliliters per minute or 90. So based on that, the battery life depends on the time base and the flow rate chosen, which can range from 12 hours to 30 hours. The second instrument I'll be talking about is Indoor Air Quality Probe. This is basically for three major chemical components, that is volatile organic compounds, carbon dioxide and carbon monoxide. And additionally, it measures two physical parameters, that is temperature and relative humidity. This is the IAQ probe. It is attached to a tablet, basically. And this is how the user interface looks like. It gives the real-time data for volatile VOC, CO2, and CO. As you can see, it gives the real-time data, and data can be logged using three methods. One is trend log graph. For a particular duration, we can take the data of the entire duration. The second one is snapshot log, where for a particular location at a particular time you can just take the data. Whereas the third method is auto run, where you can feed the date and the time where you exactly require the data. For example, let's say like 16th November, 2 p.m. to 4 p.m. If you feed it into it, it will automatically operate. The probe requires 10 to 15 minutes for stabilizing. After that, the data can be taken. And additionally, while sampling, you can also take audio or audio notes or some text notes or some snapshots, pictures. So that is the additionally, while sampling, we can do that. And the third instrument I'll be talking about is Aerosol Mass Monitor. This takes care of the total suspended particles. The speciality of this instrument lies in its ability to segregate between different particulate matter size ranges. As Dr. Bave has already discussed about PM1, 2.5, 4, and 10, it can be segregated, and it gives the data for all the ranges. So basically, when total suspended particles are measured using two principles. One is gravimetric measurement, that is direct measurement. On the filter paper, you just calculate the mass. And the second principle is the light scattering photometer, where the scattering properties of the particles are exploited, and the particles flow into different multiple channels, based on which the particles are counted and converted to mass. So this instrument basically uses the second principle, that is particle count to mass conversion. And it gives data in like a 1 minute average data it gives. So there are two modes in which you can operate it. One is continuous and the other one is manual. So for manual mode, you can, at any particular location, at any particular time, you can take the data, whereas for continuous, it gives each minute data for the entire duration. So when you're operating it for continuous mode, you can operate it for like 8 hours, whereas when you're going for manual mode, you can use it for up to 24 hours. So any study basically requires two steps. First one is data collection, and second one is processing and analysis. So as according to our schedule, you already know that after lunch we'll be heading towards Nagarkot. So on the way, we have decided to use all these three instruments and take the measurements. And this is the route map of the location, like ICIMOD to Club Himalaya. So basically, we'll be collecting data on our way. And at the hotel, we'll be installing the instruments in the rooftop, take the data overnight. And tomorrow morning, Orniko sir will be dealing with the results and the analysis part. But briefly, I just want to go through some of the points which you can think about while traveling, just how the analysis is done. This is the IAQ probe data. As I said, it gives real-time graphs. It also provides you with the minimum, maximum, and the average values. For example, what is the global ambient average of CO2? Anybody knows about that? Okay, basically it's around 390s as of 2015, but as in the northern hemisphere, it's slightly higher. It reaches to 400, 450, and since it's urban area, the CO2 which we measured was around 452. This data is actually just for to show it, to demonstrate it. We just took the reading from here to Nagarkot, and this is the analysis part. So, and CO2 doesn't have significant impact unless it crosses the threshold value of 1000 parts per million. So basically that was the average. Similarly for TVOC, volatile organic compounds, there's no significant studies being made on that. However, practitioners say that like less than 1 ppm of TVOC doesn't have much impact. So this was 0.142 ppm. That is ppb, so it's 0.14 ppm. So it doesn't have much effect. This was the analysis of the aerosol mass monitor. So we can see that the TSP, PM1, all the quantified data, we can plot the time series. And while traveling in the trip, what we want you to think about is when are the time where the peaks shoot up, like the TSP might reach up to 3000 micrograms. So that is basically because of one possible cause might be because of heavy transport congestions, or due to dusty roads, since you can see the construction activities going on due to post-earthquake road damages and everything. Also, those are some of the possible things you should be thinking about while using this instrument. And thirdly, this is MicroAeth data. This is the plot of black carbon. So in some instrument, the data analysis part is also equipped with some online softwares. This you can sign up and upload your measured data, and it gives you a plot, or you can plot it manually, both ways. In that area, what we see is, since we know that black carbon is the product of incomplete fuel combustion, BC is higher in the initial section as it's urban area, but as we go towards Nagarkot, since the vehicular movement is less, we see less BC. That is one of the possible causes. So we want you to think of some other causes why the BC is decreasing or increasing. So these are some of the points we'll be discussing about during the trip and tomorrow morning as well. So basically now we have 3 sets of instruments. So we'll on the teams that has been divided, we'll be giving these instruments, and we can measure it throughout the tour. So if you have any questions, our team is glad to assist you in this. Thank you.